Good morning, students. Previous classes we have learned about magnetism and electromagnetism. So in this lesson, what is magnetic field, what are the magnetic lines of force, magnetic flux density, unit, then electric motor, Fleming's right hand rule, Fleming's left hand rule. So far we are learning in this lesson, this chapter. Through this study we learned. So today, last class we learned about Fleming's right hand rule. We learned. No? Did you study, students? Previous questions? Yes. Okay, very good. Now, once again I am repeating the Fleming's right hand rule. So this Fleming's right hand rule only used in this electric generator. Okay. Now listen here. First stretch 3 finger. What are the finger? Middle finger, forefinger and thumb. Middle finger, forefinger and thumb. 3 fingers are mutually perpendicular to each other. So the middle finger shows the direction of induced current and forefinger shows the direction of magnetic field and thumb shows the direction of motion of a conductor. So this last class we have learned about Fleming's right hand rule. I am thinking all the students know this one. So once again, stretch 3 fingers. What are the fingers? Middle finger, forefinger and thumb. So the middle finger shows the direction of induced current and the forefinger shows the direction of magnetic field and the thumb shows the direction of motion of a conductor. Okay, today we can learn about electric generator. So electric generator or otherwise known as AC generator. Okay, another one name AC generator. Electric generator or AC generator. Now we can learn the construction. So here, which principle used in this electric generator means electromagnetism. Which principle? Electromagnetic induction. So which principle used in this electric generator? Electromagnetism principle used. All of you know what is electromagnetism. Okay. Electromagnetic induction. All of you know this. What is electromagnetic induction? What is electromagnetic induction? Whenever the magnetic flux linked with the coil, the EMF will produced. This induced EMF is called electromagnetic induction. So the same principle only we are used in this electric generator. Now we can learn how to draw the diagram of electric generator. All of you listen here. First, take a rectangular coil of wire. So those who learned electric motor is very easy. It consists of a rectangular coil of wire. This is a rotating device and the middle axle is there. Through this axle it will rotate. A, B, C, D is called armature. So just we can mark this armature. So first it consists of a rectangular coil of wire. A, B, C, D is called armature. So the electric motor we learned rectangular coil of wire. Now here the name is armature. Armature means number of coils is wounded in this rectangular coil. Okay, number of coils are wounded. So we are saying this as armature. The next, the rectangular coil of wire is kept in between the poles of a permanent magnet. So this is the north pole and here south pole. So here we can mark this poles of a permanent magnet. So two parts we marked. One is armature and the second part is poles of a permanent magnet. Now at the end of this coil, a slip rings are attached. Rings are attached. Okay, at the end of the coil, slip rings are attached, that is S1 and S2. Two slip rings. This ring is called slip rings. SLIP. Slip rings. So listen, here two slip rings S1 and S2 are attached at the end of this coil, rectangular coil. Now at the end of the slip rings, stationary brushes B1 and B2. B1 and B2. What is this? Stationary brushes. Here we can mark stationary brushes. Stationary brushes B1 and B2. The slip rings S1, S2. Here B1, B2. Through this stationary brushes, external circuits are external circuit of. So this is the diagram of electric generator or AC generator. See, first it consists of a rectangular coil of wire ABCD is called armature. The rectangular coil of wire is kept in between the two poles of a permanent magnet. At the end of the rectangular coil of wire, two slip rings are attached. At the internal parts of the slip rings, two stationary brushes are attached. Through the stationary brushes, external circuits also. So this external circuit. External circuit. So here, what are the parts? Poles of a permanent magnet, armature, stationary brushes, slip rings, external circuit. So this 5 parts you have to mark. You should draw the diagram and you should mark the parts. Okay, this construction. Now we learned about the construction of a electric generator. Now how it works, we can see. So what I told first itself told, which principle used electric generator? Yes, very good. Electromagnetic induction. The principle used in electric generator is what? Electromagnetic induction. So here magnet also there, coil also there. Now always two also perpendicular to each other. That's all of you know. See, when the magnetic flux linked with the coil, what happened? The induced current will produce. No, this induced current will be as a electromagnetic induction. Like that also here, the coil used to rotate. No, the coil used to rotate. That is what happened. The induced current produced in this coil. So this coil, this direction, see AB and CD, the same direction passes through. See first AB, CD, it passes through this slip rings and through this slip rings, through this carbon brushes B2 and B1. Through this external circuit and B2 and the current passes through B2 to B1. See first the current passes through ABCD and through this coil. At the end of the coil, which one is attached? Slip rings is attached. No. At the end of the slip rings, which one is there? Stationary brushes. Here B2 and B1. Here which one? B2. This B2 and B1. So now the current passes through here B2 to B1. Now the next half cycle, the current passes through D, C, B, A. Next, first half cycle, the current passes through A, B, C, D. Next, D, C, B, A and through the slip rings. At the end of the slip rings S1, which is attached B1. Now through this stationary brushes B1 to B2. So the current flows through B1 to B2. First half cycle, the current flows through B2 to B1. Next half cycle, the current passes through B1 to B2. So like that here rotation takes place. Each half cycle, the direction of the current will change. This direction of the current will change by using the Fleming's right hand rule. All of you know about Fleming's right hand rule. So these are the working of the electric generator. First we have learned the construction of the electric generator or AC generator and diagram. You should mark the parts. Then the working of the electric generator. Can you understand, students? So just draw the diagram and mark the parts, then write the heading construction. Which principle used in the electric generator? Electromagnetic induction. Then write after the construction and working, you have to write the detailed answer. This one, electric generator, or the question will come electric generator or AC generator. The next one we can learn about transformer. So transformer. So all of you know about transformer, no? So here two coils are there, primary coil and secondary coil also there. No, primary coil and secondary coil is there. Now see, what is the use of this transformer? The transformer is used to convert the low voltage to high voltage or high voltage to low voltage. Okay. What is the use of this transformer? Transformer is a device to convert low voltage to high voltage or high voltage to low voltage. For that only this transformer is used. Now we can see the diagram of transformer. Look at this picture, transformer. It consists of two coil, primary coil and secondary coil. So what is the principle used in the transformer is electromagnetic induction. What is the principle used in the transformer? Electromagnetic induction. It consists of two coils. What are they? Primary coil and secondary coil, insulated from each other. The alternating current flows through this primary coil. The alternating current flowing through this primary coil induces the magnetic field in the iron ring. The magnetic field of the iron ring induces the varying EMF in the secondary coil. So these are about the transformer. In this transformer, number of turns of primary coils also there and secondary coil also there. It depends upon the number of turns of the primary coil and number of turns of the secondary coil. We can see the types of transformer also. So now you know about transformer. What is the transformer? What is the principle used in transformer? Electromagnetic induction. It consists of how many coils are there? Two coils. What are they? Primary coil and secondary coil. So these two coils are insulated from each other. The alternating current flowing through the primary coil induces the magnetic field in the iron ring. The magnetic field of the iron ring induces the varying EMF in the secondary coil. Now listen, transformer are in two types. Now we will learn about transformer, and this transformer are in two types. One is the step-up transformer. Step-up transformer. Next one is the step-down transformer. So what are the two types of transformer? Step-up transformer. Next one, step-down transformer. So the transformer consists of how many coils are there? Two coils are there. No, what are they? Primary coil and secondary coil. Here the number of turns the secondary coil will be more when compared to the primary coil. Now we can see about first type, step-up transformer. The step-up transformer, it converts to low alternating current to low alternating voltage to high alternating voltage. Now see here the VS means the secondary voltage is greater than the primary voltage. So the number of coils in the secondary coil is greater than the number of turns of the primary coil. Number of turns of the secondary coil is greater than the number of turns of the primary coil. Now see the step-up transformer is used to convert low alternating voltage to high alternating voltage, and here Vs is greater than Vp. V means what? Voltage, and Vs means secondary voltage, this primary voltage. The number of turns of the secondary coil is greater than the number of turns of the primary coil. Now itself you can learn the transformer means what, which principle used in the transformer, that are the two types of transformer. This is also a brief answer. Two types. What are the two types? Step up and step down. So we have learned about step up transformer. If you learn this means very easy step down. So step up means what? Step up transformer is used to convert low alternating voltage to high alternating voltage. So here the number of turns of the secondary coil is greater than the number of turns of the primary coil. The next one, step down transformer. So we can say now, step down transformer is used to convert high alternating voltage to low alternating voltage. So we can write this, Vs is less than Vp. So the number of turns in the secondary coil is less than the number of turns in the primary coil. So number of turns in the secondary coil is less than the number of turns in the primary coil. Now you can identify the difference, step up transformer and step down transformer. So step up transformer, which one is greater? Number of turns of the secondary coil is greater than number of turns of the primary coil. But here, number of turns, step down transformer, number of turns of the secondary coil is less than the number of turns of the primary coil. So this much we have learned about electric generator and diagram, construction and working, which principle used in the electric generator. Now transformer also we have learned, two also same principle used. No? Transformer also, which principle used? Electromagnetic induction. But there are two types of transformer. What are the two types of transformer? Step up transformer and step down transformer. This is also very important question. What is transformer? What are the types of transformer? The transformer is used to convert low voltage to high voltage and high voltage to low voltage. Which principle used? Electromagnetic induction used. Now, what are the two types of transformers? Step up transformer and step down transformer. I am thinking you are clear about transformer. Okay. The next one. Yes, next one. What are the applications of electromagnet? So the electromagnet used in speaker. You all know about speaker. No, speaker also these electromagnets are used. And the magnetic train is there. No, magnetic elevation train. So the train also they are used magnet. And in the medical field also MRI scan. Nowadays any disease, the internal parts of the body, any disease there means the doctors will advise to take scan. No, so for there also this electromagnets are used. In medical field also used, speaker also used, some trains also they are used to this electromagnet. Now what is electromagnet? Permanent magnet is there. No, electromagnet is there. So electromagnet, permanent magnet always has the magnetic power. No, electromagnet, when the current is there, that magnetic power is there. Otherwise it will lose the magnetic power. So this electromagnets where and all used, speaker used, and the medical field also in many scanner, then X-ray and all they will take. No, they are also they used to this electromagnets. Okay students, so this much only this fifth lesson, magnetism and electromagnetism. So far you have learned this, nearly 3 or 4 classes you have learned this lesson, and I am thinking you studied well this lesson, and today's question you learned well electric generator and transformer. Just application, just read this, read the application, that's all, there is no question. Only these 2 questions are there today. So you have learned well students, and the half-yearly exam December 14 will start. So there how much portion completed, that much question is there. Okay, so we have to learn well and write the exam. Now listen. So you have learned this electric generator and electric motor also. Last class we have learned electric motor. No? So electric motor if you study this is very easy for you. There only one difference is there. What difference? Here slip rings we are using. They are commutator. That is split rings. Okay, which rings? Split rings. Split rings. That is only commutator. We studied this commutator. No. So here slip rings, there split rings. So here AC generator, electric generator or AC generator I told now. DC generator ask means the diagram, the same diagram, but here that is split rings you have to draw. Okay, that will be different. So mostly they will ask AC generator. So learn well all the answers. Now we can mark the question. Okay students, take your book. Now take Roman letter 1, choose the correct answer. Which of the following converts electric energy into mechanical energy? Motor. Answer is A. transformer works on AC only. So DC we cannot apply this transformer, only AC. The third one, the part of the AC generator that passes the current from the armature coil to the external circuit, that is brushes. D option, brushes. Now fourth question, the unit of magnetic flux density is the option 3, Weber per meter square. Then Roman letter 2, fill in the blanks. The SI unit of magnetic field induction is Tesla, TESLA. Then second one, the devices which is used to convert high alternating current to low alternating current is called step down transformer. Third one, an electric motor converts electrical energy to mechanical energy. Electrical energy to mechanical energy. Then fourth one, a device for producing electric current is electric generator or AC generator. Next, Roman letter 3, match the following. Magnetic material. The answer is iron. Non-magnetic material, wood. Current and magnetism, worsted. Electromagnetic induction, Faraday. Then electric generator, induction. Then true or false, Roman letter 4, true or false. First one, a generator converts mechanical energy into electrical energy. True. Then magnetic field lines always repel each other and do not interact. True. Third one, Fleming's left hand rule is otherwise known as dynamo rule. That is false statement. Instead of dynamo, you have to write a motor. Then the speed of rotation of an electric motor can be increased by decreasing the area of coil. So that's a false statement. Instead of decreasing, you have to write increasing. Fifth one, a transformer can step up direct current. That is a false statement. That is AC current. Then sixth one, in a step down transformer, the number of turns in a primary coil is greater than the number of turns in the secondary coil. That is true. Next, Roman letter 5, question number 4, draw and label the diagram of AC generator. So already I drawn the blackboard, just you have to draw and mark the parts. Then fifth one, state the advantage of AC over DC. So you have to write it. The answer is the cost of generation of AC is less than the cost of generation of DC. Second point, AC can be easily converted into DC. Third point, only alternating voltage can be stepped up and stepped down by using the transformer. Fourth point, AC can be transmitted to distant places without loss of electric power than DC. Next, sixth question, differentiate step up and step down transformer. Page number 61. Just draw a tabular column, step up transformer and step down transformer. The first point is the transformer used to change a low alternating voltage to high alternating voltage is called step up transformer. So here first point, the transformer used to change a high alternating voltage to low alternating voltage is called step down transformer. Second point is, in a step up transformer, the number of turns in the secondary coil is more than the number of turns in the primary coil. Here second point, in a step down transformer, the number of turns in the secondary coil is less than the number of turns in the primary coil. So two difference you have to write. Next question number 7. A portable radio has been built in transformer so that it can work from the mains instead of batteries. In this, a step up or step down transformer, give reason. So just note it. It is a step down transformer so that rectified DC voltage is equal to battery voltage. Hence, it can work on mains as well as on battery. Start. Roman letter 6. Second question. Explain the two types of transformer. Start. Page number 61. Types of transformer. The transformer used to change a low alternating voltage to a high alternating voltage is called step-up transformer. In a step-up transformer, the number of turns in the secondary coil is more than the number of turns in the primary coil. The step-down transformer, the transformer used to change a high alternating voltage to low alternating voltage is called step-down transformer. In a step-down transformer, the number of turns in the secondary coil is less than the number of turns in the primary coil. This next. Next, third question. Draw a neat diagram of AC generator and explain its working. Page number 60, electric generator. An alternating current generator consists of a rotating rectangular coil ABCD called armature placed between the two poles of a permanent magnet. The two ends of the coil are connected to two slip rings S1 and S2. The inner side of these rings are insulated. Two conducting stationary brushes V1 and V2 are kept separately to the rings S1 and S2 respectively. The two rings S1 and S2 are internally attached to the axle. The axle may be mechanical rotated from the outside to rotate the coil inside the magnetic field. Outer end of the two brushes are connected to the external circuit. So, and mark the parts and working. Side welding working. This construction is working. When the coil is rotated, the magnetic flux linked to the coil changes. This change in magnetic flux will lead to generation of induced current. The direction of induced current is given by Fleming's right-hand rule. Along ABCD in the coil and in the outer circuit, it flows from B2 to B1. During the second half rotation, the direction of current in along DCBA, the coil and the outer circuit, it flows from B1 to B2. So that next mark it. Okay students, fifth lesson, all the questions you have marked. And then today's assignment question, electric generator and transformer. Detailed answer is the construction working of the electric generator or AC generator. Next to that, types of transformer. Just study and write as the assignment. Thank you.